Okay, I think everybody should be here now. I welcome you to this webinar about graphs in action, interaction, and animation techniques for developers. My name is Benjamin Niedermann. I'm a software developer at yWorks, and I'm happy to welcome you to this 8th episode of this series about the art of graph visualization. In this series, I show you how to create not only beautiful, but also meaningful and useful graph visualizations. And with this, I mean that you can derive new information from your connected data using such graph visualizations. In the very first episode, so in the first 5 episodes, I gave a broad overview of about the most important aspects for such graph visualizations, including the layout, but also the styling and interaction techniques, giving a lot of examples. I also discussed how to transform the data into graph structures. And now in the remaining episodes, so from 6th to 9th, I would like to talk about how to create such graph visualizations programmatically, so taking a really practical point of view on such graph visualizations. And today I would like to talk about graphs in action, so interaction techniques and animations. Why the combination of interaction and animation, typically when you do some interaction, you change the state of your graph visualization from one state to another, and then you would like to also show this transition in order, for example, to preserve the mental map of the viewer of this graph visualization. So in this webinar, as I already said, I will take a very practical point of view. So the idea is that we actually do some coding in this webinar. To that end, I will use yFiles for HTML, so also TypeScript. If you come from another platform, so let's say C# or Java, this is no problem. Typically, yFiles has the very same API on all of these platforms, so it should be easy for you to understand what is happening in this webinar. Besides yFiles, I will also use our playground so that you can actually try out these examples on your own. I will have a short look at this playground to show how it works. In this playground, what you can do is you can use yFiles and basically the entire power of yFiles. The idea is that on the left-hand side, you have the possibility to write some code, you can create some graph visualization and also the styling. And on the right-hand side, you have this canvas where the graph visualization is drawn. So the playground runs entirely on the local machine, on your local machine. So for example, this runs now on my computer. Just in order to give you some idea how this playground works and how you can use it, first of all, there are many examples that you can have a look at here. If you go to show examples, and you can scroll through these examples and try them out. Further, what you can do is you can edit here this code and, for example, create a graph and then draw this graph. The idea here is that you are basically given 2 global variables, namely a graph variable here. This represents the graph structure that you would like to draw. So here, for example, I create a node, and then after that, I create further nodes and edges, and this gives me a tree structure. And the other global variable that is given is a graph component representing this canvas on the right-hand side. So, and here at the end of this example, we just tell this canvas, okay, it should draw this graph. So this graph object is registered already with a graph component. It should draw this graph using a tree layout, and it should use some animation which takes 1 second. And then this graph visualization is created. So if I change this here, for example, to more nodes, we get a larger tree visualization for this very small graph. So, in contrast to the entire yFiles package, you only have this small snippet where you can actually put your concrete example, and you don't have any overhead that you need to write, for example, for your web application. So you can easily try out yFiles. And this I will also use during this webinar. So let's go back to the slides. In this webinar, I will also use a running example that I have used in the episodes before. And in these episodes, I showed you different kind of visualizations for this example. And this comes from Discogs. This is a Wikipedia-like database that contains millions of entries about artists and also about the releases and the music groups, for example, they were member of. And the nice thing is with this database, you can explore this on their website. You can click through these entries. But what you also can do is you can extract this entire data using their API. And we did this. And so this gave us a small example data set that we can use in this webinar. So what I've done for this webinar is I extracted some artists and also the music groups they are members of. So for the artists, we have the information of the name, but also in which music groups they are, and then also the number of releases. And for the groups, we have, of course, the name, the first and last release, the genres, and some numbers about the releases. Then this data we will use in this webinar in order to create a visualization that we can use to learn something about the collaborations of the artists. And in the episodes before, I showed different ways how to do this. So I also showed you how to extract the temporal component and show this in a way where you can learn something about the temporal collaborations. In this webinar, I would like to take a bit simpler view because I would like to focus on interactions and animations rather than, for example, on the layout. So this time, the idea is that we represent the data as basically two layouts of the same graph, namely as a tabular layout in which we have these artists that are not part of the radial layout. And then the radial layout has one artist in the middle. And then around this artist, we have the groups the artist is member of. Here in this example, we have Paul McCartney, and we have many groups he's member of. And then in the next layer, we have the artists that are members of these groups again. And then we can continue creating this graph visualization. And the idea is that we will do this interactively. And I want to show you this in our playground. You can also access this via this link, which should also be now in the chat. So if I click on this link here, I come to the playground. And here the example is we can now explore this example about this artist. So when I press run, what we will see here is that only artists are shown, but we haven't selected any artists. So we can hover here over these artists. We have some nice animations for these artists, like growing or enlarging them shortly. And when I click on this artist here, for example, this graph visualization is created. And what I also can do is I now can hover over these single music groups. And then I get already a preview of the artists that are members of this group. So here, for example, the Beatles. And if I continue clicking on this, I get the next layer of this radial drawing, and so I can continue exploring this graph visualization. So I can click here on John Lennon, and so I can continue learning about the collaborations of the artists around George Harrison. So this is basically the idea what we will do in this webinar. And the idea is that we will strongly focus on interactions and animations. And I will do this by first considering the basics. So just explaining how interaction is done in yFiles. Then I will talk about some kind of filtering techniques which I have used for this exploration mechanism that you have seen. And then in the last part, I will talk about animations. So how to create animations that visualize this steps between states of the visualizations. So let's start with the basics. Basically, when you want to integrate interactions into your visualization using yFiles, you need to do this via this graph component that I've shown you in the very first example, in this Hello World example. And this graph component has multiple or has one property called input mode. And these input modes are basically the point of access for interactions, where you can control how a user can actually interact with this graph component. And there are two major types of input modes, namely the graph viewer input mode, and on the other hand side, the graph editor input mode. The graph viewer input mode is for viewer-centric applications, so where it's really about exploring the data and learning about the data without changing the actual graph structure. And the editor-centric application is more about, I really want to change the graph structure. So let's go to an example here for the viewer-based or viewer-centric application. I've just taken this demo about this Wonderlands, where you can move around here on this graph, and you can explore this graph by clicking on the nodes like this, and then the graph extends. So it's very similar to the idea that I've presented in the example before. So this would be a typical viewer-centric application. A editor-centric application is Wired Live, for example. Here it's really about changing the graph structure, but of course you could also think about another applications where it's more like changing. You have some kind of data model that you want to visualize, and then you want to add, for example, some nodes, and you would like to add edges and so on. And all this is already integrated basically in yFiles, especially these graph operations like creating nodes, creating edges, connecting them. You don't need to do this on your own, but you can basically use this input mode. So the thing is that both modes are really powerful, and it would take a lot of time to discuss both. And this would actually exceed this webinar today. So I decided to focus on the viewer-centric application, where it's only about how the user can interact with the graph visualization without changing the structure. But there will be another webinar upcoming, which will be about interactive graph editing, where I then will talk about the graph editor input mode. So let's talk about the graph view input mode in this webinar. This input mode, as I already said, gives you as a developer the interface to control the interactions with the user. So this, if you go to the documentation, and this is just a small snapshot or screenshot of this documentation, you will find a lot of properties that you can configure. And these properties basically determine how the user can actually interact with this. So for example, you could say, okay, the clickable items of the graph components are nodes, but not the edges. But you could also say, okay, you would like to have some kind of default cursor. You could define things about the context menus and so on. And you can also enable and disable such input modes. So here I don't want to go through all of these properties, but what you should learn from this slide is that these input modes give you a lot of possibilities to specify how the user can actually interact with your graph component. And furthermore, and this is also very important, is they offer you a lot of events. So this is really a small set of these events that are provided by these input modes. And these are triggered on user interaction. So this gives you basically the anchor point to react on the interactions. And again, I don't want to go through them in detail, but later on I will show some of them in the coding example. So, but if you already want to know or play around a bit with these events, what you can also do is you can go to this demo here. and just try out. So here the idea is that you can basically activate some of these events, and then you can see how the graph components react. So what I can do is I can click here on this node, and what you can see that the graph editor input mode in this case has thrown some events, namely an item has been clicked, and then I have used the left click, and there are many different events that you can go through, and you can play around with this and try out how this works. Especially when coding web applications or using this graph component, this demo can be actually helpful to also understand how these events works and how they work together. So here I just invite you to have a look at this demo, and I will go back to the slides, continuing with the coding examples. So maybe one thing that I also should mention here is that these two large input modes, so the graph viewer input mode and the graph editor input modes, do not consist only of properties and events, but they again consist of more input modes, so sub-input modes that you can further configure and which you can also enable and disable to say, okay, I would like to have certain interactions completely disabled for this graph component, or you enable them and you could just use the default properties, and or you can then customize this. So this is basically the idea with the interactions, that you work on these input modes, you configure them, you register listeners for the events, and then you can react on the interaction of the user. So this was a lot of theory. Now I would like to go more to also a coding example. And the first example is quite simple, but it should show you some principles. And the idea is very simple. One moment, I just have a short video here. The idea is that when we move on top of these artists, they get highlighted. So I can restart this video here. The mouse goes over this single artist nodes, and the idea is that each artist node becomes highlighted when I hover over it. So a really simple interaction. And you can find it under this link here with part 1. So what we need to do is, first of all, we need to create an input mode. Here in our use case, the graph viewer input mode, and we register this with a graph component, telling it, okay, we would like to have a viewer-centric mode. And what we then also do is that we register an item hover input mode, which is responsible for the interaction that is done by hovering over items. And in this case, this is a sub mode of our graph viewer input mode. So I register this here. And then I also specify already some property saying, okay, I would like to discard invalid items, or I don't want to discard them, which basically means this defines the behavior, how items are treated that are not handled by this input mode. Here you could also specify more properties. So for example, you could say, okay, I only want to have nodes that are triggered by hovering over this. Important to say is that when registering in such a sub-input mode, you need to do this before registering this before registering the entire input mode with a graph component. Because otherwise you will get some exception which tells you you should do this. This is just in order to ensure that everything is configured correctly. And then what we also need to do is we want to register a highlight manager. In the last episode, I also have already shown this. The highlight manager, the idea is that it handles the highlights, so of your nodes, of the edges. And basically it's a container where you can add items, and these items will be highlighted on your canvas. So speaking very roughly, actually it does much more, and it also can be customized much more, much more. But basically, it's a container where you add new items. So in our use case, I just react on the item hover input mode and on the changed listener, so the hovered item changed listener event. Here, the idea is that an event is triggered when I leave an item or when I enter an item by hovering it. So I just check whether I have an change in hovering over this item. And now what I do is that I also check that this item is a node, because I'm only interested in nodes, but not the edges. What I also could have done is I could have specified this directly in the constructor that I'm only interested in nodes. And then I tell the highlight manager which style to use, which depends either on the artist node or on the music group node. In case of the artist node, I use a rectangle. For the music group node, I use a circle, but this is just a short side note. And as I already said, this highlight manager works basically as a container where you can add items, and then this will create this highlight. And what we also need to do is, of course, that we need to clear all items before we do this with this adding. Otherwise, at the end, everything will be highlighted where we have hovered over. So having a look at the playground, we can try out this. I just run the example. Here I can hover over this, and each time the artist is then highlighted. And if you go here to the source code, you can find this here, basically the very same coding example. Here I create this graph viewer input mode. Here I've actually said, okay, here I said, okay, I only want the nodes to be hovered items, and then the rest is what I've already presented. By the way, for the playground, this is not the entire code for the example, but there are some regions that you can expand, and there you can find more code. But for this part, I just want to focus on this. So this already showed you how to do this in a very basic way using these item listeners. And with this, it's actually, you can integrate many of these interactions because you just need to react on some kind of events. No, not. So next, I would like to go to the bit more advanced techniques about filtering, which I also used in this example. So what do I mean with filtering? With filtering, I mean that I have loaded a large graph, for example, which I call entire graph in the following. And the idea is that I would like to get a view on this graph, not only a visual view, but actually a data view on this graph, where I've excluded certain nodes and certain edges. And to that end, I can use a filtered graph, which expects the entire graph, and also two predicates telling this filtered graph which nodes and edges should be part of this filtered graph. So in this case, I just have this predicate saying or telling me whether a node is orange or not, and the same for the edge. And so I just tell the filter graph, okay, it should only consider orange nodes and orange edges. So what we see here is that, for example, this node here is excluded, but also this blue edge here is also excluded. And especially this is maybe also important to mention, if I remove a blue node here, for example, then of course this orange edge will be also removed because it has no target node anymore. So this is done automatically. The nice thing of this filtered graph is that the nodes and edges are the very same instances in this graph structure as in this graph structure. So what you can basically do is you can take this node here from the filtered graph and ask in the entire graph, for example, about the degree. without using any mapping, because it's the very same instance, so the very same object that you use here. So basically the nodes and edges are only keys that you use on the graph object to access the information behind your graph structure. And this is what I want to use for the interaction that I've shown you for this exploration process, where I click on a artist node, and then we get this radial layout, and then we click on another node, and then this expands again. So maybe again, I can show you this shortly. I use this filtering technique for basically this interaction here, where I click on a node, and then I click on another node. And what happens is basically every time I click on one of these nodes, I add further edges to this graph structure, and also further nodes, namely the music group nodes. Or put differently, so if I start this example again here, at the beginning, I don't show the entire graph, but only a filtered graph that only consists of the artist nodes. And then when I click on one of the artist nodes, I change this filtered graph by telling the filtered graph, okay, now you should also contain the edges, the corresponding, and also the corresponding music group nodes. And and with this, I can continue basically creating this graph visualization on the right-hand side. So let's become a bit more concrete. So I go back. So here the idea is that we have the left-hand side of the nodes, which are inactive nodes, or which I call inactive nodes. And on the right-hand side, we have nodes that are called active. And the idea is that I only show artist nodes and active music group nodes, but I will never show inactive music group nodes in my visualization. And how to do this? What I do is basically I create a filtered graph based on the entire graph. So the entire graph contains all music group nodes, all edges, all artist nodes. And then I also have this predicate here, which says, okay, node is contained in the filtered graph. Either it is an artist node or it's an active node, so it's an active music group node. And at the beginning, I have set this tag, so it's just a Boolean tag to false for every of the nodes. And then I also do the very same. I say, okay, all edges that I show in my visualization, or that are contained in the filtered graph, should have an active tag. So there, this active should be true. And at the very beginning, only the artist nodes are part of the filtered graph. And what I also do is that then I tell the canvas object, so our graph component, that it should use the filtered graph instead of the entire graph for the visualization. So this graph component actually only sees the part of the filtered graph. It does not know anything of the entire graph. And what we now need to do is we need to somehow integrate this interaction. So what happens if I click on a node? And for this, I write this function here, handle node, which expects the node where I've clicked on. And the idea is that when clicking on a node, then I set the incident edges and the neighbors just active. And then I update everything. So what I do here is I set the node itself active. So it could be that I have an artist node on the left-hand side, which is then also inactive. And then by setting active, I said, okay, it moves to the right. And then I also say, okay, I go through all nodes, go through all incident edges of this node. And here it's important to use the entire graph and not the filtered graph, because the entire graph knows all edges. The filtered graph knows at the beginning no edges. And then I just take the opposite of this edge, and this is the neighbor. And I set this neighbor active, and I set also the edge active. And now the filtered graph contains also the neighbors and the edges. And finally, what I need to do, and I should not forget, is to tell the filtered graph and now it's ready, and the predicates has changed. So for this, I just tell the filtered graph, okay, there is a change. You need to update yourself. And further, what I also introduce is a very simple reset function that just goes through all nodes and all edges and set all these nodes and edges inactive. And I then also tell the filter graph that the predicates have changed. So how to combine this? Again, what we do is we use an input mode. This time we use the graph viewer input mode directly. We say, okay, the clickable items are the nodes. And then we react on click events by registering an event listener for the item clicked listener here. And here the idea is that we first take the node that has been clicked and we check, okay, if this node is inactive, this means I have clicked on it in the table, then I reset everything in my visualization. So maybe there is already some radial layout on the right-hand side. And then I define the new center node, which I store one level above. So not directly in the click listener in order to keep it. And then I handle the node by defining the predicates as shown before. And then I run the layout, basically creating this tabular layout and on the right-hand side of a radial layout using the center node. And further, we don't need to do anything further because now the filter, this one layout only works on the filtered graph and does not know anything about the other parts that are still hidden. So let's have a look at this again in the playground. I run it. So here the idea, all of these nodes are inactive. I click on one. Now the node becomes active and all its neighbors becomes active and all these edges, so they become part of the filtered graph. I click on the next node. These nodes become again active and also the edges and so on. This is the way how it works. And if you go to the source code here, you can find here that a definition of the filtered graph, which is basically what I've shown. And here in the install exploration, so I have extracted this and put it into a function. You can actually find the source code for installing this click listener. As you can see here, I've added some further things about the background. So maybe you have recognized this when I click here on this. What happens is that this blue ring disappears and then appears again. This is done here in this clear background and add background. If you're interested in how this is done, you can have a look there. And also I refrain from talking about how the layout is created, but please feel free to have a look at this function one layout. But altogether, this showed you already some important technique in yFiles, how to work with graph visualizations and hiding parts of the graph for interaction. If you want to learn more, I refer also you to the documentation about filtering. There's a large developer guide and it also contains an article. But there are also many demos in our demo set that are about filtering and also then about use cases using filtering. Here, for example, the large graph aggregation is a very nice demo for this, which basically uses same techniques for filtering the graph and then only showing the filtered graph, deciding by which nodes should be actually shown using interaction. And this brings me to the last part, namely animations. As I already said, interaction and animation always often goes hand in hand because when you have some interaction, you would like to show the transition between two visual states, and animations help you to maintain the mental map of the visualization. So what can you actually visualize? There are different types of things that you can, or what you can animate actually. Of course, you can animate changes in the graph visualization. So for example, the movement of nodes. Let's have a look at this. So what you can do is instead of having a direct jump between visual states, you can actually visualize this transition. So if I take this node here and I put it here, what now happens is that the layout is one in the background, and then this and after that there's some kind of animation. So let's have a look at this. Maybe I can find a more complex example. Yeah, so what you can see, the remaining layout remains similar, but with this animation, it becomes really intuitive what is happening in this visualization. Then what you can also do is you can animate the content of the elements. So for example, of the nodes in order to show changes in some kind of attributes. Or of course, what you also can do is you can change the color and shape in order to somehow show highlighting, let the viewer focus on some certain elements. So here in this demo, you can really try out different types of such animations. And what you also can do, of course, is you can change the background and animate this. Here, this is an example about process mining, where we animate the background in order to show some flow, how this flow goes through this network here, showing also a heat map. And finally, what you can also do is you can animate the viewport. So in order to really ensure that the viewer only sees certain parts. So here, this is an example in the playground of another episode of this webinar. Here we have a large graph, and I click here on this node, for example, and then the viewport changes, and we can actually move through this graph automatically. And this is also a nice way to animate such graph visualizations, focusing on certain parts of the visualization. So how to do this? I would like to start with some basics again. There is one interface, it's called iAnimation, which is basically used for such animations in yFiles. And for example, also when you apply a layout and you call morph layout on the graph component, it basically uses this framework in the background. So the idea is that this iAnimation does not have a lot of methods, and you don't need to know this normally, but it has some static methods, some static factory methods that can create such animations, and there are different types of animations. So later on, we will have a look at the create graph animation. Here, the idea is that you have some input layout and you have an output layout, and you would like to animate the transition between these two layouts. You can also create animations for single nodes, for example, or for some labels for edge segments. And again, it's only a part of the list of animations that you can do, but there are furthermore. Moreover, you can combine these animations. So what you can do is you can say, okay, I have created multiple of these animations objects, and now I would like to play them as a parallel animation. And then you can also say, okay, I would like to have a sequential animation. And of course, you can also combine these animations that you then get again with each other, creating really complex animation systems, actually. So let's start again with a simple example. Here, the idea is that I just start the video, okay? So the idea is that when I hover over these nodes, moment I restart the video again. So when I hover over the nodes with the mouse, then the nodes become a bit larger, and then they become smaller again, just highlighting this hovering effect. And this again should show you the principles how to do this, and then after that we will have a look at a more complex example. So again, we are using this hover item change listener event as before, and we assume, okay, this item that we get is a node, and if this node is null, then we don't need to do anything. And what we now do is we create an animator, and this animator just needs to know the graph component. And then what we can do is we can create two animations, namely two node animations, based on the entire graph. And I just want to have the node. And in the first animation, I just enlarge this node by 10 pixels in each direction. And this animation should take 0.2 seconds. And then I also create a shrink animation. And this time I just use again the original layout of the node. So basically this animation tells me, okay, enlarge the node, and then the second animation tells me, okay, shrink it back to the original size. And then what I do is I create a sequential animation which consists of grow and shrink in this particular order. And then the only thing that I need to do is I need to call the animator to animate this entire animation, and with this I already get the result that I want to have, like this enlarging and shrinking this node. One comment about this, for these kind of animations, it's often useful to also allow user interactions so that the user can start multiple animations. I can show why in the playground, so let's go there. So when I hover over these items, I have this animation here. And let's go to the part where I've created this. It's here in this glow animation. And let's say that I don't allow the user interaction. The problem now is that if I go here, you see, okay, it needs to wait until the interaction is ready or finished, because I only have very small animation times. You don't see this very well. So let's say, let's change this to 2 seconds, which is really long. So what you can see here, I can hover to the next node and nothing happens. And now the animation does not start or starts just after the other interaction. So let's say that we put it to true again. And now I can start multiple interactions. Of course, this doesn't look very nice because the delay or run times for these animations are too long, but with short delays, this works quite well. So this should already show you how to use this animation framework in general. What we also often suggest is to use east animations to create visual appealing shifts between states. This is also quite simple. You just call grow.create east animation. Basically, what an east animation does, it has a slow beginning, a fast middle, and then a slow ending. Which often seems to be more a natural animation, and such kind of animations can be created easily. So let's have a look at a more complex example, namely about this, where I place my node over my mouse cursor over a node, and then the nodes fly to this node. So basically, I can show this again. So I have this artist here, and when I put my mouse over the Beatles, what happens is that the nodes above, so for example, Paul McCartney, flies to the Beatles, gives me some preview, and when I stop hovering, they go back to their original position. And I would like to show you and sketch how to do this. Again, what we do is we use the hovered item change listener. Again, we say, okay, we check whether, or we just assume that this item is a node. And what I also do is I create this animator object based using the graph component, and I also allow user interaction. So next, what I do is I go through all nodes of the entire layout, and I create target node layouts where the layout should be. And I fill this target node layouts with the original layouts. So layouts is basically a map that stores for each node its position and is updated after each layout run. So basically, this is target node layouts contains after this line all original layouts of the nodes, so also all original positions. And now what I can do is I can override some of these positions in order to create this animation. So what I do is, if this node is a music group and this node is active, so it is also part of this radial layout, I go through all of the neighbors of this node. This is done here in this line. Here I just pass the node to the neighbors of the entire graph. And then I filter all the neighbors that are inactive, so they are still on the left-hand side. And then I tell, or then I compute a new layout for this neighbor node, which is basically placed below the node. So this is a little helper function, which basically returns a rectangle that is placed below the node. And depending on how many neighbors I've already considered, so many steps below the node will it be placed. And this gives me this nice stack below the artist, below the music group node. So now I have these target node layouts. Many of them just contain the original layouts, and some, namely the neighbors, also contain the new position or contain the new position. And now what I need to do is I need to create an animation that uses these positions for transition. So what I do here is I create a graph animation. It expects the entire graph, preferred duration, and then also the target node layouts. And what it does, it updates the graph. So it changes the layouts of the graph nodes to the layouts given by the target layouts, and it will animate this transition. So this is also basically done when morphing a graph using one or morph layout on the graph component. And finally, I need to animate this, and this already gives me the entire animation. In particular, if I stop hovering a node, so if I go on a blank part of the canvas, what will happen is that I only I only pass the original target layouts, or the original layouts of the original graph visualization. So basically what then happens is that the nodes are automatically placed back in the table. So basically this animation creates the movement towards this music group node, but also the animation backwards. So what I mean with this is when I click here, and here, when I hover over this node, the new node layouts are the positions below this music group nodes. And when I stop hovering over this node, the positions become the old positions again. And this gives me this nice animation. And often you can work with such techniques in order to create really complex animations. And this already explained how to create such flying nodes, for example. And with this, I would like to go to the outlook of this webinar. So I've talked about interactions and also animations and how to combine them. But of course, there are many things that I haven't mentioned because the time is, it would basically exceed this webinar here. So what I, for example, didn't mention is folding. Folding is basically also a technique of filtering, or where you use filtering. Basically, you have these group nodes, and what you can do is when you click on these group nodes, you can expand them, and then basically these nodes are not hidden anymore. And again, this can also be done using filtering by telling the graph structure, which nodes actually should be included and which of the nodes should not be included. And then, of course, it would be nice to make these nodes smaller if the content nodes are not included. There are also many demos on this, but also some articles in our developer guides about this. So the next thing that I also haven't talked about is background. So the idea that I actually can animate and interact with the background. Here in this example, I have this nice kind of heat map, or not a heat map, but it basically shows how the nodes are connected. Such animations and interaction techniques I haven't shown. And finally, also WebGL animations. Here I've already showed you some of the demos. So feel free to go to our demos page and have a look at this. And finally, and most importantly, also I think, is that we haven't talked about how to edit a graph interactively. So having a look at this editor-centric application. And as I already said, there will be a webinar about this in August about interactive graph editing, where I will talk about how to use the graph editor input mode and related concepts. And with this, I would like to wrap up the main part of this webinar, and I now would be happy to answer your questions. So I will have a look at the chat and go through your questions shortly, and then I will try to answer them. I think there's one question with which I can start. I just pasted it here so that you can also read it. Let's see. So the question is there the possibility to integrate own animation? So I think what is meant whether or can I only assemble them based on the given one? So I think what is meant is we have these static factory methods that you can use to create these animation objects, and then you can assemble them. But actually, what you can also do is you can implement this interface that's called iAnimation on your own. And basically what you need to do is to implement one method, which is called every time when the visualization is updated, so with each frame, so then you can react on each frame and update your visualization, and there you can make really complex things like so what you could do is that the viewport moves along a certain path, and this path animation is then maybe such an implementation of this eye animation. So you're not restricted to this, to these kind of animations that you can create with the factory methods, but you can also create your own. The next question is about touch screens. One moment, I also so what about interaction with touch devices? Is this also possible? These input modes, there we have a lot of different input modes that you can configure correspondingly and customize, and we also allow touch gestures that you can use, for example, to intuitively move nodes, create nodes, resize nodes. So there's a lot of things already implemented, but of course you can also implement your own ideas with these frameworks. And then I think there's one question left. So it's about the layout. One moment, I just copy it here. So how is the layout done during interaction? Is it always recomputed entirely? And here it's also important to say that often for interactions, it's important that the layout does not change completely. I've shown you this small demo with the hierarchic layout where only parts are changed. And actually, our layout algorithms typically also give you the possibility to integrate such in interaction. So for example, the hierarchic layout supports the incremental mode, which is basically made for this. But also other layout algorithms offer you the possibility to take an existing layout, take this as a sketch for the new layout, which often is then a good way to go to create such interactive layouts. In order to maintain large parts of the layouts while only small parts change. I think this was the last question. And with this, I would like to end this webinar. I thank you for your attention and wish you happy diagramming.